Hey everyone, and welcome back. We're diving into a research paper today that really made me think.
Oh, yeah.
Yeah, it's called Can 1B LLM Surpass 405B LLM Rethinking Compute Optimal Test Time Scaling?
Okay.
And it's super fresh. It just came out on February 11th, 2025.
Hmm. It's a fascinating paper because it kind of shakes up what we think we know about AI,
Right.
you know, especially this idea that bigger is always better.
Right, exactly. Like, we always assume the bigger the AI, the smarter it is,
Oh,
right?
yeah.
But this research is like, hold on a second. It might not be so simple.
Yeah, and it all comes down to these things called large language
That
models.
coins?
LLMs, you got it. You
Yep.
probably use them every day without realizing it. They're the brains behind like all the chatbots, AI assistants, all that cool tech.
Oh, yeah, for sure. So basically, this research is diving into how to make these LLMs even better.
Exactly. They're looking at a technique called test time stealing, or TTS.
CTS. Okay, so what is that, like, in simple terms?
Well, think of it like this. It's a way to give your AI a boost when it's trying to solve a tough problem.
So like a power-up. Yeah, like a power-up. Exactly.
I like that. So what were the researchers trying to figure out with this TTS thing?
They had two big questions. First, is there, like, a best way to use this extra computing power to make LLMs better at solving problems?
Oh, okay, that makes sense.
Especially those really tricky ones.
Right, so it's not just about giving them more power, it's about using it strategically.
Exactly. And their second question was even more interesting. They wanted to see if they could use TTS to make a small LLM outperform a much larger one.
Whoa, 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 hold on. You're saying they wanted to see if a David could beat a Goliath in the AI world.
Haha, pretty much.
Yeah.
And to test this, they decided to focus on math problems.
Math. Okay, interesting choice. Why math?
Well, it's a great way to measure how well an AI can reason and think logically,
Yeah.
right or wrong answers.
I see. So what kind of math problems are we talking about here? Like basic addition and subtraction or?
Oh no, we're talking challenging stuff. They use data sets called Math 500 and AM24,
AM24. What's that stand for?
the American Invitational Mathematics Examination. It's for like the top math students in the US.
Whoa, okay. So this is not your average high school math quiz. We're
Yeah.
talking serious brain power stuff.
Yeah. And to make it even more interesting, they use 3 different ways to use this test time scaling.
3 different ways.
Okay.
I'm all ears. Tell me more about these methods.
Okay, so the first one's called best of n, or BON.
Best of N. Got it.
Basically, you give the AI like multiple chances to answer the same question, and then you pick the best answer.
Ah, so it's like giving the AI a multiple choice test and letting it choose the answer it thinks is right.
Uh-huh. Yeah, exactly. The second method is called beam search. It's a bit more systematic.
Beam search. Okay, I'm intrigued.
The AI explores different solution paths, kind of like navigating a maze.
Oh, so it's not just guessing randomly, it's actually using a strategy to find the best answer.
Exactly. And then the third method is a mouthful.
Hit me with it.
Diverse verifier tree search, or DVTS. It's like beam search, but even fancier.
Mhm.
It pushes the AI to be more creative.
Creative? How can math be creative?
Well, it encourages the AI to explore solutions that might not be super obvious at first.
So instead of just sticking to the main road, it's taking those back roads to see if there's a shortcut.
That's a great way to put it. And you know what?
Yeah.
They found that you can actually get these smaller LLMs to beat the bigger ones using these methods.
Really? No way. Did they actually see that happen? Like, did David actually beat Goliath?
Well, they absolutely did. It was pretty amazing. In some cases, the results were really surprising. Like they found that a 1B LLM using TTS could outperform a 405B LLM on some of those Math 500 problems.
Hold up. Did you say a 1B LLM beat a 405B LLM? That's insane. The smaller AI was like over 400 times smaller.
It's crazy, right? And that wasn't the only time it happened. They also had a 3B LLM that beat the 405B LLM on some tasks, and even a 7B model that outperformed something called the O1 model.
O1 model, what's that? Some kind of secret weapon?
Well, not exactly a secret weapon, but it's a pretty strong LLM. It's made by OpenAI, one of the top AI companies out there.
So the fact that a 7B model could beat it is a pretty big deal then.
Oh, yeah, for sure. And then get this, they even had a tiny 0.5B LLM that beat GPT-4 in some cases.
No way! GPT-4, that's like the king of language models right now. Everyone's talking about it.
I know, right? It's wild. So yeah, this research is really shaking things up in the AI world.
It's showing that it's not just about size anymore, right? There's more to it.
Exactly. The researchers call this compute optimal, TTS. It's all about finding the sweet spot between the size of the LLM, the problem you're trying to solve, and how much extra computing power you use.
So it's like finding the perfect recipe for AI success.
You got it. But there's one more piece of the puzzle we need to talk about.
Okay, lay it on me.
These things called process reward models, or PRMs.
PRMs. Okay.
Yeah.
What are those all about?
Think of them as like a coach for the AI. They give feedback to the LLM as it's working through the problem, guiding it toward the right answer.
So like a math tutor whispering tips and tricks to the AI as it's tackling those equations?
Uh-huh. Exactly. And the researchers found that having a good PRM can make a big difference in how well the AI performs.
Okay, so it's like having a great coach can really help a smaller athlete punch above their weight.
Yep. That's a great analogy.
This is getting really fascinating. But let's talk about something you mentioned earlier, problem difficulty. Didn't the researchers have some interesting things to say about that?
They did. They actually questioned the usual way of thinking about how hard a problem is for AI.
Oh, really? How so?
Well, typically people look at how many AIs can get a problem right on the first time, try and use that to decide how hard it is.
That makes sense. So the more AIs that fail, the harder the problem.
Yeah, but the researchers said, hold on, that might not be the whole story.
So just because a lot of AI struggle with a problem doesn't automatically mean it's super difficult.
Right. There
Okay.
could be other things going on. So they came up with a different way to measure difficulty. They called them absolute performance thresholds.
Absolute performance thresholds. Okay, what does that mean exactly?
Basically, if an LLM can get a problem right over 50% of the time, it's considered easy. If it's between 10% and 50%, it's medium, and anything below 10% is hard.
That makes sense. I guess it's like a more accurate way to judge how tough a problem really is for an AI.
And for you as a listener, it means this new way of measuring difficulty is more in line with how we humans judge difficulty.
Okay, I can see that. So
Yeah.
we've got these different test time scaling methods, these AI coaches called PRMs, and a whole new way of thinking about how hard a problem is for an AI.
Uh-huh.
This is a lot to take in. Where do we go from here?
This is where things get really interesting. The researchers dug into all the quirks of those PRMs, and it turns out they're not all created equal.
Quirks. Like what? Do some PRMs give tougher feedback than others?
Not exactly tougher, but they found that some PRMs have biases towards longer or shorter answers.
Wait, so you're telling me the AI coach can actually influence how much the AI talks? Like if it's a chatbot, will it give me a novel when a simple yes or no would do?
Uh-huh. You got it. Some PRMs kept pushing the LLMs to use more tokens. Those are like the building blocks of language,
Right.
even when a shorter answer was just as good.
That's so funny. It's like having a friend who always over-explains everything, even when you just need a simple answer. Not very efficient.
Exactly. It shows how important it is to understand these little quirks in PRMs and choose the right one for the job. But that's not all. PRMs can also be picky about how you pick the final answer from the LLM.
Wait, what? There's more than one way to pick an answer.
Well, think about that best of n method we talked about.
Yeah.
The AI gives you a bunch of answers and you pick the best one, right?
Yeah, you pick the one with the highest score.
Right. So with some PRMs, that works great.
Yeah.
But others actually do better when you combine the scores in different ways.
Oh, wow. So it's like the AI coach is saying, don't just focus on the final answer, show me your work. I want to see how you got there.
That's a great analogy. It really highlights how much we still need to learn about these PRMs and how to coach AIs the right way. We're just scratching the surface here.
It sounds like it's not just about building bigger and bigger AIs anymore. It's about really refining that training process, understanding all the nuances, and making sure those AI coaches are in tip-top shape.
Exactly. And the researchers really drove this point home. They said we need to be way more thoughtful about how we use rewards in computing power, especially as these LLMs get more and more powerful.
It's like they're saying, hey, hold your horses, everyone. Before we all rush out to build the next mega AI, let's make sure we're doing this right. Let's understand the subtleties, the quirks, the potential problems, and let's train these AIs in a way that unlocks their full potential without creating any unintended consequences.
Couldn't have said it better myself.
Yeah.
This research is a great reminder that we're still in the early days of figuring out AI, and there's so much more to discover.
Okay, so this research focused on math problems, but I'm already thinking, could these same principles work for other complicated things, like writing code or even doing scientific research? Are we on the edge of a new era in AI where these smaller, more efficiently trained models become the real stars?
That's the million-dollar question, and this is where it gets really exciting. Just imagine if we could apply these techniques to other fields. The possibilities are endless.
I'm already picturing these smaller, more agile AIs revolutionizing everything from medicine and engineering to art and music. It's pretty mind-blowing. But let's not get ahead of ourselves. Are there any limitations to this research that we should keep in mind?
Well, one thing to remember is that this study focused specifically on mathematical reasoning. While the principles they uncovered are super interesting and potentially game-changing, we need more research to see if they apply to other areas.
So we need to see if these AI coaches can be just as effective at training AIs to be expert coders or scientific geniuses.
Exactly. And remember those PRM quirks we talked about? We need to dig deeper into those biases and see how they might show up in different tasks. What works for math problems might not work the same way for writing poetry or composing music.
Right. We don't want to accidentally train AIs that write code that's way too long or scientific papers that are technically correct but impossible to understand.
Exactly. It's all about finding that sweet spot between efficiency and effectiveness.
This is what I find so thought-provoking about this research. It's not just about making AI more powerful, it's about asking the right questions, exploring new ways of doing things, and making sure we develop AI in a way that's both beneficial and responsible.
Couldn't have said it better myself. And the best part is this research opens up a whole new path for exploration. It's a call to action for everyone who's excited about the future of AI.
Okay, before we wrap up, I have to ask. What does all this mean for the future of AI development? What about the balance between model size and using computing power in a smart way? Are we moving towards a world where smaller, smarter AIs are the new norm?
That's the big question, right? It
Yeah.
really makes you think. If we zoom out and look at the bigger picture, this research challenges this idea that we need to keep building these massive energy-guzzling AI models.
Yeah, it's like saying, hey, maybe we don't need to keep making AIs bigger and bigger. Maybe we can get amazing results with smaller, more efficient AIs that are better for the environment and easier to train.
Exactly. And it also means AI could become way more accessible. If you don't need a supercomputer to run powerful AI, then it opens up the doors for so many more researchers and developers.
That's such a cool thought. It could truly democratize AI and lead to a wave of new innovations. But let's be real for a second. Some people might be hearing this and thinking, okay, this all sounds great for math problems, but what about the real world? Things aren't always so black and white out there.
That's a fair point.
Yeah.
But remember, even the messiest real-world problems can often be broken down into smaller, more manageable steps. And that's where these efficient training methods in AI coaching can really shine.
So it's about choosing the right tools and strategies for each challenge. And maybe size isn't the most important thing after all.
You got it. This research gives us a glimpse into a future where AI breakthroughs might not come from just brute force, but from smarter, more elegant training methods.
Right.
It's about working with the AI, not just trying to make it bigger and bigger.
Well, there you have it, everyone. We've taken a deep dive into the world of AI and explored some mind-blowing ideas. We've seen how smaller AIs can actually outsmart the giants and how clever training methods can really unlock their true potential.
It really makes you wonder what's possible, right? What if we could apply these techniques to other fields? What incredible things could we achieve?
It's so exciting to think about. I hope this deep dive has given you a lot to ponder. What were your biggest takeaways? Do you think we're on the cusp of a new era in AI? A world where smaller, smarter AIs are leading the charge? We'd love to hear your thoughts. And until next time, keep exploring, keep asking questions. That's what the deep dive is all about.
They did. They actually challenged the traditional way of thinking about how difficult a problem is for an AI.
So how do we usually figure out how hard a problem is for AI? I'm guessing it's not as simple as just asking it, hey, is this tough for you?
You're right about that. The typical way is to look at how many AIs can get the problem right on the first try. But the researchers argued that this isn't always the most accurate way to measure difficulty.
So just because a lot of AIs fail a problem doesn't automatically mean it's super challenging.
Exactly. There could be other factors at play. So they decided to use a different approach. They set these things called absolute performance thresholds. Basically, if an LLM can get a problem right, over 50% of the time it's considered easy. Between 10% and 50% is medium, and anything below 10% is considered hard.
That seems like a more precise way to judge how difficult a problem really is.
And what's important for you is that this approach is more realistic and lines up with how we humans would naturally judge difficulty.
Okay, so we've got these different test time scaling methods, these AI coaches called PRMs, and a whole new way of thinking about how hard a problem is for an AI. This is a lot to take in. Where do we go from here?
Well, this is where things get particularly interesting. The researchers started to dig into the quirks of those PRMs, and they discovered some pretty unexpected things.
Ooh, this is where we get into the nitty-gritty, right? Give me the lowdown on these PRMs. What kind of quirks did they find?
It turns out these PRMs aren't all created equal. They have their own little personalities, you could say.
Personalities. That's a funny way to think about it. So are some like stricter than others?
Well, not exactly stricter. but they did find that some PRMs had biases toward longer or shorter answers.
Wait, are you telling me the AI coach can actually influence how wordy the AI is? Like, if it's a chatbot, will it give me a novel when a simple answer would do?
Yes, exactly. Some PRMs consistently push the LLM to use more tokens, which are basically the building blocks of language, even when a shorter answer would have been just as good.
So it's like having an AI assistant that gives you a super long-winded explanation when all you needed was a simple yes or no, not very efficient.
Precisely. It highlights how important it is to understand these biases in PRMs and choose the right one for the job. But that wasn't the only quirk they discovered. PRMs can also be picky about how you choose the final answer from the LLM.
Okay, now you've really piqued my curiosity. How many different ways can there be to pick an answer?
Well, remember that best of n method we talked about, where the AI gives multiple answers and you pick the best one.
Yeah, like choosing the one with the highest score.
Right. So with some PRMs, simply taking the highest scoring answer worked best. But others actually performed better when you combine the scores in different ways, almost like weighting different sections of an exam.
So the AI coach is saying, hey, don't just focus on the final answer. Show your work. It's like getting partial credit on a math problem, even if you didn't quite nail the solution.
That's a great analogy. And this really highlights how much we still need to learn about these PRMs and how to coach AIs effectively. We're only just beginning to scratch the
It
surface.
sounds like it's not just about building bigger and bigger models anymore. It's about refining the training process, understanding the nuances, and getting those AI coaches in top shape.
Exactly. And the researchers really hammered home that point. They emphasized that we need to be a lot more thoughtful about how we use rewards and computing power, especially when we're scaling up these LLMs to be even more powerful.
It's like they're saying, hold your horses, everyone. Before we rush to build the next AI behemoth, let's make sure we're doing it right. Let's understand the subtleties, the biases, the potential pitfalls, and let's train these AIs in a way that maximizes their potential without creating any unintended consequences.
That's a great summary. This research is a powerful reminder that we're still in the early stages of understanding AI, and there's so much more to explore.
Okay, so this research focused on math problems, but I can't help but wonder, could these same principles apply to other complex tasks? Like, what about writing code or even scientific discovery? Are we on the cusp of a whole new era of AI development where smaller, more efficiently trained models become the real game changers?
That's the million-dollar question, and this is where things get really exciting. Think about it. If we can apply these same techniques to other fields, the possibilities are mind-boggling. That's the million-dollar question. Like, it really makes you think. If we zoom out and look at the bigger picture, this research challenges this idea that we need to keep building these massive, energy-guzzling AI models.
Yeah, it's almost like they're saying, hey, maybe we don't need to keep making AIs bigger and bigger. Maybe we can get amazing results with smaller, more efficient AIs that are better for the environment and easier to train.
Exactly. And it also means AI could become way more accessible.
Uh,
If you don't need a supercomputer to run powerful AI, then it opens up the doors for so many more researchers and developers.
That's a fantastic thought. It could really democratize AI and lead to a wave of new innovations. But let's be real for a second. Some people might be hearing this and thinking, okay, this all sounds great for math problems, but what about the real world? Things aren't always so black and white out there.
That's true. But remember, even the messiest real-world problems can often be broken down into smaller, more manageable steps.
Right. And that's where these efficient training methods and AI coaching can really come in handy.
So it's all about finding the right tools and strategies for the job. And maybe size isn't always the most important factor. You got it. This research gives us a glimpse into a future where AI breakthroughs might not come from just brute force, but from smarter, more elegant training methods. It's about working with the AI, not just trying to make it bigger and better.
I love that. It's a whole new way of thinking about AI. So to wrap things up, we've taken a deep dive into the exciting world of AI and explored some truly mind-blowing ideas. We've seen how smaller AIs can actually outsmart the giants, and we've learned how clever training methods can unlock their true potential.
And it makes you wonder what other possibilities are out there.
Right?
What if we could use these same techniques in other fields? What amazing things could we achieve?
The possibilities are endless. I hope this deep dive has sparked your curiosity and left you with some food for thought. What were your biggest takeaways today? Do you think we're on the verge of a new era in AI? A world where smaller, smarter AIs are at the forefront? We'd love to hear your thoughts. And until next time, keep exploring, keep asking questions. That's what the deep dive is all about.